And we have Joseph with us. Can you come onto the stage? Can we hear you?
Hey, thanks for having me, Adam, and I'm
Joseph,
excited
how
to
you
be
doing, man?
here.
Joseph, where are you coming? Where are you calling in from?
Jersey City, New Jersey.
Jersey City. We're not
Yeah,
too far away. Not too far
not too
away.
far away, other side of the country. So,
No, I'm in New York, so I'm not
oh,
too far.
okay,
The
gotcha.
other folks, yeah, the other folks are a little bit further. I'm gonna give you the stage, and without further ado, Joseph, take it away.
Sounds good. Thank you. Hello, everyone. My name is Joseph. I'm a senior data engineer over at Netflix. I wanted to take this time to talk about some of the things that I've learned in my career over the past 10 years, almost a decade now. And whenever I've ignored these things, it has come back to bite me, and hence the name, Not Causing Chaos. All right. So the most important thing as a data engineer is data modeling. Your data model is your product. Without a good data model, no amount of optimization, no amount of fancy tools will help, because that is what your end user is going to consume. And when we talk about data model, there are a lot of nuances, but at a high level, there are primarily five types of tables. The fact, which represent actual events that happen in real life. So like a order or some event on a website, those are considered facts. It's something that happens. And then there are dimensions, which represent business entities. So consumer, product, seller, merchant, etc. So these are the people who interact with the business. It can also be things like date. And then there are bridge tables, which are mapping tables. Many to many relationship maps are stored in the bridge tables. And a kind of recent one is one big table, where you typically take a fact table and left join every dimension that is in that fact. And what this allows you to do is serve it as a table, and people don't have to worry about joins. People don't have to kind of do the joins multiple times. It's just basically we are sacrificing space to improve performance. And then finally, there's the summary table. You can think of it as data marts. These are essentially the final stage or final layer, if you will, of tables that you present to end users. Typically, people who use this are using it via a BI tool, so that when they access the summary table, they are not incurring costs because it's already aggregated. The next most important thing is data quality. And we always want to make sure our data is valid before stakeholder uses the data. Because unlike backend engineering or other parts, when our data is out and people start using it, it's hard to change the actions that have been taken by the business user based on your incorrect data. When there are too many data quality issues, it causes a loss in trust by the stakeholders. And then you get questions like, hey, is this data accurate? I don't think so, et cetera, et cetera. But on the other hand, you also don't want too many data quality checks, and you'll that means you'll get a lot of alerts, and your on-call engineers are going to suffer. So finding the balance is key. As for implementation, you typically want to do something called a write audit publish pattern, where you create your data, but before you expose it to your consumers, you do your data checks, and then only if it passes, you expose them. If it doesn't, you raise an alert and fix that issue. I want to quickly touch upon some types of data quality checks. The standard ones are like table constraint checks. These are checks where you make sure that your columns don't have nulls, they're unique, they have all values populated, etc. Then there are business rule checks. These are specific to the type of data you're working with. So something like start date cannot be um, after end date, things of that nature. Then there are schema checks, so you don't break downstream processes. Metrics variance check is an important one, where you monitor key metrics over time and make sure it doesn't vary too much. So if you see an outlier, that's something off. But you do have to account for seasonalities. For example, on days like Thanksgiving, there might be a spike in revenue. Then finally, there's reconciliation check. This type of check is typically used when you want to make sure that you're not losing any data due to any code bugs. So what you do is you take your output, you compare the number of rows against the input driving table. Typically, you'll have one driving table in your inputs. All right, the next one is functional programming patterns for pipelines. When you write your pipelines as functions, especially the transformation part, it reflects how humans think. When we think of data pipelines, we think take table A, take table B, join them. So we think in a series of steps, and functional programming enables us to represent that in code more succinctly. And it ideally should be atomic, but the definition of atomic is a little tricky. It basically means it should do one thing and only one thing, but that one thing you need to decide for yourself based on your code base and your team's expertise. And finally, a key part is that your function, especially the transformation and loading function, should be idempotent. What that means is no matter how many times you run the function with the same input, it should not result in duplicate data or partial data. This is typically done with overwriting partitions when you think of data pipelines. If you don't have this, any issues will require you to clean up the output and all the outputs generated as part of your pipeline and then restart it. And it becomes an extremely tedious process. However, if you make your pipelines idempotent, you don't have to worry about that. You could just rerun it as many times as you want. You will, and you can trust that you won't have duplicate data.
Joseph, real
Yeah,
quick, can I
yeah,
step in? Do you mind putting your presentation in full presentation mode?
sure.
The meaning of the slides. Maybe slideshow, top right, yeah.
Oh, there we go. Sorry. Is that better?
Thanks.
Yeah, sorry about that. Thank you. Yeah, I wanted to give a quick screenshot of functional programming, or well, as functional as you can get in Python. Here you can see how we can combine transformations in order. That'll also make it easy to test and easy to debug, especially if they're idempotent. You could just whip up a REPL and just test one function at a time. It just makes it so much easier to debug and also to rerun, especially with backfills. LLMs for coding, also known as back in the day copy paste from Stack Overflow. When you are using LLMs for coding, you need to be very clear on what you want done and how you want it done. If you do not specify how, it's going to use a very unconventional way or a way that is not in line with your organization. And also, please make sure to review the code before using it. I wanted to go over a specific example. I wrote up this script a few hours ago where I wanted to create a Python script to generate TPCH data. TPCH is just a benchmarking data set. Most companies use to benchmark their query performance, and there are utilities to do this. When I give a prompt just saying what I needed to do, it wrote like this huge script, like 300 lines, and it didn't work. However, when I specified what and how on the left-hand side, I said, do this, use these tools, accept these as input parameters. It produced perfectly working code, which I reviewed and it did run. So always specify the what and how, especially when you're doing auto generation. All right, the next one is testing your code. Make sure to test your code. It might take a few hours, but I can assure you it'll save you like 10 to hundreds of times in debugging and maintenance, especially if it's a pipeline that runs frequently. And tests also serve as working documentation because it represents the reality of your code. And when you write tests, don't just test for the happy path, test for at least one happy path and multiple failure paths. That will show the next person or you 6 months from now what not to do with a function. And then finally, this for advanced use cases, if you have multiple tests, run them in parallel. They could usually be independent. Finally, automate repeated tasks. If you find yourself doing the same thing over and over again, make sure that you automate it because you are prone to make mistakes and you could essentially save a lot of time. Two of my favorite ways are makefiles and async scripts. So makefiles are essentially a way where you can alias this long commands with simple commands and you can chain those commands. Basically, it's a way of aliasing complex commands and it makes things easy to run. And this one is async coding. So what I generally do is if I am running a test pipeline and it takes like 5 minutes, I'm not going to stay on the terminal and see what runs and what doesn't. So I just run it in the background and I do my own thing, and it'll notify me when I'm done, when it's done. And you can think about doing this as a pipeline as well. When you deploy a pipeline and it builds, it takes a long time. You just run it in the background and you will be notified when it's done. Finally, a lot of the problems, not the tech part, but the approach part and the design part have been solved. And I recommend you read these 3 books: Data Warehouse Toolkit, Designing Data Intensive Applications, Fluent Pythons. The concepts in these books still hold. The tech has gotten so much better with cheap storage, table formats, but using and when you adopt these underlying like foundational concepts, it'll make your pipelines more resilient and you wouldn't have to deal with so many issues when you're on call. Okay, so that was it. Do we have time for questions?
We first of all, this was excellent. Thank you very much. And you could see in the chat is bustling with activity and with excitement. So Joseph, thank you
Right.
very much for that. We don't really, but let's.
Oh,
Lots of people want the slides, and people have been sharing the podcast that you recently had appeared on.
okay.
I'll just ask maybe one last thing here. Miguel is asking, what would you say is the optimal balance between data completeness and data availability?
Mhm.
How do you mitigate sacrifices made when wanting to serve data as real time as possible?
Again, I'm going to say the most computer science answer possible. It depends, but I'll give you a specific example. If you're dealing with revenue, finance stuff, you want data completeness. However, if you're dealing with directional numbers, so think of charts that just go like this, you're typically fine with sacrificing completeness. Um, so it's a balance. But the key thing is, it's good that you're asking the question because that needs to be brought up with the stakeholder, and you guys need to make that decision together.
Joseph, thank you very much for joining us. Everybody wants the slides. We will send them and package them into the videos once they are all released. But for people that are tuning into the audience, I will just say if I had had this slideshow or had listened to your presentation 10 years ago, it would have saved me probably years of frustration and
Oh yeah,
agony.
I learned
And
that the hard way.
these
Yeah.
were Oh my goodness! So many of these things. First of all, just it is brilliant distillation of wisdom that feels hard won, right? Like it's I hear the pain that is underlying all of this, and I share some of it. And for anybody who can help to who could use this insight to avoid some of this pain, Joseph, thank you very much for helping them.
Thank you for having me. Have a good rest of your day.